Hi everyone, I am Cikgu Tati Sutrianti binti Syukur from Sekolah Menengah Sains Muzaffar Shah Melaka will be sharing with you a lesson in Physics Form 4 syllabus 6.4, the thin lens formula. Before we move on to the content, let's have a look at the learning standard. The first learning standard is to investigate the relationship between the object distance u and image distance v, and to determine the focal length of a thin lens formula. And the second one is to solve problems using lens formula for convex and concave lens. What is the thin lens formula? The thin lens formula gives the relationship between object distance u, image distance v, and focal length f for a lens as 1 over u plus 1 over v equals to 1 over f. Let's have a look at these two photos. These two photos shows the image of a different object distance with a lens of the same focal length. The first photo is where the position of the camera lens close to the object that produce a large image. For the second photo is where the position of the camera lens is far from the object that produces a small image. Now, we are going to discuss experiment 6.3. You may refer to your textbook, page 259, and the aim of the experiment is to study the relationship between the object distance u, image distance v for a convex lens. The inference of the experiment is image distance v is influenced by the object distance u. The hypothesis is when the object distance increases, the image distance decreases. The manipulated variable will be the object distance, the responding variable will be the image distance, and the fixed variable will be the focal length. Now, let's have a look at the apparatus used. We are going to use a convex lens with a focal length of 10 cm, a lens holder, a candle. The candle will become the object of the experiment, a wooden block, white screen, and a meter ruler. The first procedure is to light up the candle, and then you adjust the position of the lens until the object distance is equal to 15 cm. And then you adjust the screen in order to obtain a very sharp image on the screen. Next, you measure the V by using a meter ruler, and then you repeat procedure number 2 and number 3 for U equals to 20, 25, 30, 35, and 40 cm. So this is the arrangement of the apparatus done in the lab. This is the object, which is the candle, the lens, and the screen where the image is formed. All the data obtained from the experiments are tabulated in a table. We have 4 columns in a table. The first column is for the object distance, second for the image distance, the third column is for 1 over u, and the last column is for 1 over v. Let's analyze the data. The first question will be, you have to plot the graph of 1 over v against 1 over u. So here I have plotted the graph for u. The y-axis represents the 1 over v, and x-axis is for 1 over u. Next, you have to find the y-intercept. The y-intercept is where the graph intercepts the y-axis. As you can see here, the value of intersection is 0.10 centimeter to the power of -1. Next, you have to find the gradient. Before you do the calculation, to get the gradient, you have to draw a very large triangle on the graph. Then you do the calculation by using the gradient formula. Then the gradient you obtain is negative 0.1. Next, number 3. Deduce how the values of the intercepts relate to the focal length of the lens. From the graph, we know that the y-intercepts represent the 1/f, where f equals to 10 cm. And then number 4, write down an equation to relate between the object distance u, image distance v, and focal length f of a lens. So, in order to obtain the equation, we are going to use the equation of a straight line y equals to mx plus c, where you substitute the c equals to 1/f and the gradient equals to -1. Then you will get the thin lens formula. 1/f is equal to 1/u plus 1/v. Next, state the relationship between the object distance u and image distance v. The relationship is when object distance u decreases, the image distance increases. Or you may write u is inversely proportional to v. Precautions to be taken to increase the accuracy of the results of this experiment. This experiment involving light. So this experiment should be done in a dark room. And this experiment also involving a measuring instrument, a meter ruler. So another precaution that you could write is the position of the eyes is perpendicular to the scale of meter ruler to avoid parallax error. For a real image, when u increases, v will decreases and the image becomes smaller. Or you may write u is inversely proportional to v, or u is inversely proportional to the size of image. When using the lens formula, there are several rules you have to obey. We have the convex lens, which has a positive value of the image distance. It will produce a real image, whereas for a concave lens, which has a negative value of the image distance, it will produce a virtual image. Now, let's have a look at the questions. An object is placed 30 cm from a convex lens with a focal length of 20 cm. How far from the lens is the image? So, the information obtained are u equals to 30 cm and f equals to 20 cm. You are asked to find the v. So by using the thin lens formula, you will get the v equals to 60 cm. Next, what is the magnification produced by the lens? By using the magnification formula, m equals to v divided by u, the magnification produced is equal. And what is the characteristics of the image? So from the ray diagram, the image is real, inverted, and magnified. Let's move on to the next question. An object is placed 10 cm from a convex lens with a focal length of 20 cm. From the question, we know that u equals to 10 and the focal length equals to 20. So you have to find the v. Once again, use the thin lens formula, do the substitution, and then the v equals to negative 20 cm. What magnification does the lens produce? The lens will produce the magnification equals to 2. And what is the characteristics of the image? So from the diagram, we know that the image is visual, upright, and magnified. Question number 3. An object is placed 30 cm from a concave lens with a focal length of 20 cm. How far from the lens is the image? So you have to find the v. And the u is equals to 30 and the f equals to 20. But don't forget this is a concave lens. So when you do the calculation, don't forget the negative sign on the f, and you do the calculation, you will get the v equals to negative 12 cm. What magnification does the lens produce? The lens will produce the magnification of 0.4, and the characteristics of the image form is visual, upright, and diminished. Question number 4. A concave lens with a focal length of 25 cm forms a visual image of an end at a distance of 20 cm from the optical center of the lens. What is the original position of the end? So the information you get, the focal length equals to 25 cm, the image distance v 20 cm, and you have to find the u. Do the substitution and then you will get u equals to 100 cm. Next, you have to draw a ray diagram to show the formation of a visual image of the end. So this is the symbol for a concave lens. First, you have to draw the principal axis, and then you draw the focal point, then the object, and a ray which is parallel to the principal axis is refracted and appears to come from the focal point. The next ray is when the ray travels to the optical center. It will travel in a straight line without being refracted, and the intersection is where the image is formed. Now we have a complete ray diagram. Question number 5. Diagram 11.2 shows the formation of an image by a convex lens. The focal length of the lens is 6 cm and the height of the object is 2 cm. The focal length is 6 and the height of the object is 2, and another information you will get from the diagram is the u equals to 9. Okay, do the calculation and then you will get the v equals to 18 cm. And then you calculate the height of the image. To calculate the height of the image, we are going to use the formula for magnification, which is m equals to the height of the image divided by the height of the object equals to v divided by u. Then you do the calculation and then you will get the height of the image equals to 4 cm. So now we have reached at the end of this topic. I hope this video will help you to understand the topic better. Thank you for watching, and I hope to see you in the next video. Bye!